Alright, hello everybody. This is a brief video for ESM 303 lab, sort of showing you how to start looking at your ELK data. What I've got here is the data set from your class only, from the Thursday lab only. Alright, you will be doing an analysis of the complete data set from both lab sections. So you won't get the same results as me, probably, but I'm just going to show you a couple of steps here, how to look at the instructions for this report, how to convert into percentage of time spent doing different things, and we'll look a little bit at graphing and ANOVAs. Now, it's important to make sure that you read your instructions very thoroughly, so this ELK behavior lab report document right here. All right, great. I'm actually going to change my display capture to the primary monitor. Perfect. There we go. So you've got this Roosevelt ELK behavior lab report instructions document. This shows you exactly what you need to do. Okay, you're going to be really just conducting an analysis on a hypothesis that you generate. So the dependent variable is going to be ELK behavior, or amount of time spent doing each behavior, and there's some other there's some independent variables that you can choose between. You could also just say, hey, is there a difference between male and female ELK behavior? You could say, is one behavior most common among Roosevelt ELK? Those are the two sort of standard issue hypotheses, but you can develop your own, okay? Develop your own hypothesis and then do the right test. You don't have to analyze every possible combination of independent and dependent variables. But I'm going to show you how to get started in doing that right here. Okay. One thing that's mentioned here is the data analysis tool pack. Excel won't always have this activated by default. So if you want to get this tool pack working, and when it is working, you will see this little button right here. Let me zoom in on that for you. You'll see this little button right here, this data analysis button under the data tab on the top right. Okay. When that button's there, you have all these different data analyses you can do, including a single factor ANOVA and a t-test, the two types of tests which you're likely to use to analyze this data. Alright, if you don't see that data analysis button under the data tab in Excel, you can go to File, Options, Add-ins, and at the bottom you'll see Manage Excel Add-ins and this little Go button. You hit Go, and you make sure that the analysis tool pack is activated. Now, I've got the Real Stats add-in on mine, which if you're curious about for your group project, I can show you where to get it. You're going to want to usually have your Solver add-in activated as well, but you can ignore Euro currency tools if that's there. The Real Stats package lets you do all sorts of additional analyses, which are really, really handy. And I'll show you how to use it if you come talk to me during office hours. For us, we're going to use the built-in statistical package for Excel. Okay, the first thing you have to do is take all of this data and convert it into percentages. Now, thankfully, everybody observed for 420 seconds. Remember, this first row of data is example data. If it's still there when you see the full data set, don't worry about it. Here's the trick. I'm going to go right over here to this table that's already set up for you on the right, and I am typing. I'm going to zoom in to make it a little more legible. I'm going to tell it, take this cell here, all right, divide it by 420, and then multiply that number by 100. That'll tell me the percentage of time that ELK spent doing the resting behavior. So this is all going to be percentages. So I put in equals, and then I click. I'm going to actually do parentheses there. I'm going to click that cell. All right, that's going to tell it take the value from that cell, divide that value by 420. Okay, close parentheses, multiply that number by 100. Now, when we have the full data set, it's possible that not everybody will have observed an individual elk for the full 420 seconds. The other lab section might have had an elk leave and walked away. It was no longer visible. So I'm going to actually change this slightly. We're going to go with equals, open parentheses, this value, the time spent resting, divided by the total seconds observed. Now, you need to put a $sign in front of the J here, so that when we drag this equation to the right, it doesn't transpose the cell that it's calling for here. That'll make more sense as you have to do more complex data analysis, but for now, just bear with me. That value times 100, when I put that in, that should tell me the percentage of the total time that the elk spent doing that behavior. Now I can just grab this and I can drag the lower right corner of this cell to the right. All right. And you see what this does is it moves the cell that I'm referencing in the function over by 1. Now because I put the $sign before the J there in my function, it will not move that column over if I move the function over. But I did not put a $sign before the number 5, which means that if I drag these values down, it will transpose down, which is what we want. All right, so anyways, I go back over to this table, I highlight all of these cells, and then I grab the lower right and I drag it down, and boom, there's a beautiful conversion. Now everything is in percentages. It's not bad. If you don't like how many decimal places there are here, this is very excessive, you can just go to the Home tab on Excel, and under Number right here and near the top, there's a little button that can reduce the number of decimal places. It's kind of nice. All right. So now we've got that data there. Now when we're doing figures, okay, we want to always graph average values. So remember, your data set's going to look slightly different, but these are the principles. So I'm going to make myself a row called average, okay? And all I have to do is type equals and then the word average, and then I open parentheses, and then I click and drag all of those cells, and that's going to let me take the average of those values. So on average, our elk spent 21% of their time resting. That's what that tells us. I can now do the same thing I did before, where I grab the lower right of that cell and I drag it to the right, and then the function just moves over, so now the referenced cells also can move over. You're going to also want to calculate your standard deviation so that you can put error bars on your figure, and really you want to, in my opinion, you want to calculate your standard error. So I'm going to make a row for standard deviation and a row for standard error. All right. Standard deviation's easy. You just put equals STD EV dot. You want to do it for the sample dot S. Open parentheses, and then select those values, and that's just going to spit out your standard error, your standard deviation. Now your standard error is a little more complicated because your standard error is calculated as the standard deviation divided by the square root of the sample size, which sounds frustrating, but Excel can handle that easily. We just type equals and then click the standard deviation value and then divide it by SQRT. That's going to say, hey, give me the square root of a number. And now you could count your sample size, or you can tell Excel to count these cells. All right. Boom. And that gives us the standard error there. Okay. Not bad. Good deal. So now we've got standard deviation, standard error, and average values. I'm going to show you a cool trick for generating a graph right here. And actually, this is a good Excel trick, and that's the use of the control key. So if I highlight, I click and drag these values, and then I hold the control key. So I am currently holding down the control key, and I am now going to click and drag these average values. What I've done is I have selected separated pieces of the Excel sheet, but Excel sees this as if these were right together. So it's going to, all it sees is the resting, the traveling, the eating, the vocalizing, male aggression labels, and then the average values. Now, if I go to insert a column, a 2D column, clustered column, there's a beautiful figure that shows how much time was spent doing each of these behaviors. All right? Now I'm going to delete the embedded chart title because we don't like that. I'm going to delete the grid lines because we don't like those. I'm going to go hit this green plus sign and add axis titles. Okay? And the y-axis here should be something about time spent, or you can type out percentage of time spent. Put that there, or you could type in time allocated if you want it to be a little more scientific. And then in parentheses, you can put that the unit is percent, so people know that it's not number of seconds, it's the percentage of their amount of time that was allocated. All right, very good. X-axis, we could label it as behavior. All right, and that's just fine. There it is, it's labeled. We're also missing error bars. Adding error bars to graphs, there's a little video about how to do it already on Canvas. I'm going to show you how to do it right here, though. Go ahead and click your figure, hit the green plus, hit error bars. Okay, don't use the error bars that it gives you by default. These are not real error bars. Instead, hit the little caret to the right of the word error bars. Here you go, you got more options. And over here, you're going to see error amount on the right side. And you can say custom, specify value, and then just tell it what you want those error bars to be. I want them to be standard error. The positive and the negative error value should both be, there we go, like that. Both be the same, both your standard errors. Cool? Hit OK, and there we go. Now this is a full completed graph that shows how much time was spent doing each behavior, and this is pooled across male versus female elk. And there it is. Now you need to do an analysis of this data, and analyzing the data, okay, we're going to just do that in another worksheet. I'm going to open up a new worksheet and go data analysis. I know I'm working fast, but you can always, backtrack, listen to what I'm doing here again. Let's go ahead. I'm zooming out. I'm moving this over. I'm going to take these labels right here, and then I'm going to click Control and take all the raw data, not the averages, the standard deviations, or the standard error, and then check it out. If I hit Control C, now I've got all of that data, and I can just bounce it right over to this new worksheet, and there it is. The data of all the time spent doing each of these, or the percentage of time spent doing each of these behaviors. Now I just go Data tab at the top, Data Analysis tab, Data Analysis button, ANOVA single factor. There it is. The input range, I just hit the little arrow and I select all the inputs right here, all the data there. Everything's grouped by columns. I selected the labels, so if you do that, make sure you say labels are in first row. Then output range, hit the little plus sign, and just tell it where you want it to put the statistical output. Hit enter, boom, there it is. In this case, we've got some important values here. The degrees of freedom are important, the p-value is important, and oftentimes the F statistic, the test statistic, is important. So I'm highlighting those. This value right here is 3.9 times 10 to the negative 6th. That means that there is much less than, there's much less time. The p-value is much less than 0.05. Therefore, we reject our null hypothesis, and there is some difference in the amount of time spent doing each of these behaviors. Okay? Now, really, when you're doing this, if you find that a certain behavior, no elk were ever observed doing it, don't include that in your analysis. Just delete that and then do the analysis. All right, very good. So all this tells us in this ANOVA, it doesn't tell us which behavior the elk spent the most time doing. All it actually tells us is that elk spent more time doing one thing than other things, or at least one of these values, these averages, is different than the other averages. We cannot trust my output here because I've got a zero term for the vocalizing. That's no good. And then male-female aggression was such a small thing. It's probably showing us that there was no male-female aggression. But look over here. Did they spend more time traveling and eating than resting? The air bars don't overlap. Maybe. You would need an additional analysis for that, and I can show you how to do that for your group project report. But this sort of analysis would be fine for for the elk behavior lab report. So there's an ANOVA, there's a figure, there's one other thing you might do, which is compare male versus female behavior, which isn't too tricky. I'll show you how to do that right here in another data sheet. I'm going to go MVF. All you need to do is get the data organized into two columns. So bear with me here. I'm going to select female, male, and then what they are doing. Okay. Actually, I'm going to get a little bit sneaky with it, and I'm going to select this data here, so all of the labels of male v female, and then I'm going to hold Control and select all the percentage data. All right? Control C to copy it, and then I go over to MVF, and I'm going to right-click here. There'll be an option for pasting values. You don't want to paste functions or equations here. You want to paste those raw values, the outputs. Boom. I paste it. Remember, just pause, rewind if you need a refresher on that. Or watch this at 0.5 time speed. However you want to do it. All right. So now we got male, male, female, female. I'm going to select all this data. I'm going to go to this button under the Home tab that is Sort and Filter. I am going to Custom Sort. I am sorting by column A, sorting A to Z. And that's going to reorganize our data. So now we've got the female data, we've got the male data right here. Okay? I forgot to include my labels of what these behaviors are, but that's fine. I'm going to right-click row 1, insert, go back here, select those labels, Control-C, go back over there, and then Control-V. And I'm going to Control-Z to undo that, and I'm going to actually paste them right here. There's all the behaviors, female, male. Now, if you wanted to run a t-test on, say, did females or males spend more time eating, that'd be easy enough to do. I'll show you what to do right here. So I'm going to merge these cells and make this be my eating. I'm going to make a column for female and a column for male. I'm going to take this eating data for the females, Control-C, copy it, Control-V, paste it here. This eating data for the males, I'm going to Control-C, copy it, and I'm going to Control-V, paste it right there. I'm going to need the same stuff, average, standard deviation, and standard error. Okay? So, equals average, open parentheses, selected, enter, equals stdev dot s, open parentheses, selected all, enter, equals standard deviation divided by sqrt, open parentheses, count, open parentheses, selected, close parentheses, enter. Grab all these, drag them over to the right, and boom. Just that easy. Okay? Now check this out. I'm going to select F, M, hold Control, select the averages, insert 2D column, and there's a chart. Get rid of the extraneous stuff that we don't like. All right, don't forget to label your axes. You'll lose points if you don't label your axes appropriately. And then I'm going to add error bars, not too hard. Green plus, error bars, caret, more options. And sometimes it won't immediately give you the options of selecting the data, but you've got these different tabs here. And right there on the far right tab, you've got custom, specify values. The positive error value is here. and the negative error value is also here. There you go. Now those are the real error bars, and just looking at this figure, also don't forget to label those axes. I'm just running out of time, so look at this figure. You can see there's probably not going to be any difference between these two, but we have to actually do the data analysis. So we go to the data tab at the top. We hit the data analysis button. And what we're doing is a t-test, all right? We're going to go to sample assuming equal variances. Trust me, we just need this because the sample size is different between the two. You'll learn about testing for normality and testing for variances and stuff like that if you continue with statistics. I'll help you for your group project with those tests. Anyways, to sample assuming equal variance, hit OK. Variable 1 range, that's this, just the data, don't include the averages. Variable 2 range, that's this, just include the data, don't include the averages. Hit enter. Select labels, because I did include the labels, the F and the M. And then give it an output range. And I'm just going to put it right here next to my figure. Slap enter a couple of times, and boom. There we go. We can see that our p-value, and we always want to use our two-tailed p-value, all right? Our p-value right here is well above 0.05. So there's essentially there's a 36% chance that we saw these results if our null hypothesis was true. All right, so we don't have enough evidence to reject our null. We provided evidence here to support the null, that there's no difference in the amount of time that female or male elk spend eating. And there's a whole analysis for a t-test. An ANOVA, a t-test, those are the two that you can choose between, really. If people had a bunch of different adult or juveniles, those could be done as a t-test with their different behaviors. That's the system. All right? I hope that made things a little clearer. And if you ever want to chat about doing this sort of analysis, I love Excel analysis, just drop by my office. I'm happy to help you out. And that's going to end our recording. Thank you for watching.